Okay, today we'll start talking about the work-energy theorem and then how it applies to the real world. One of the problems here is that this is a concept that's really difficult to understand, and even if understood well, it's hard to apply. So, we want to find out how the work-energy theorem really works. So that's the whole objective of this chapter. According to the theorem, the work done on an object equals to the change in its kinetic energy. And the kinetic energy here is denoted by Ke. The work done is denoted by W. So the work done on an object is equal to the change in the kinetic energy of the object. Right. So so it follows that if the net work done is zero, then the change in kinetic energy is also zero. Okay, so that's pretty much what this equation says. So so let us take an example. Let's take an example of a situation where we have a block of mass m that is raised by a height h to here. So it goes from position A to position B. Okay, so here we assume that there is an external force acting on the block that just balances out the force of gravity, the weight of the block. So it raises this block from here to there. And this block of mass m is raised very, very slowly, okay, by a height equal to h. So since it's being raised very, very slowly, okay, uh, the the velocity of the mass is near zero most of the time. So, and also the mass starts at rest and ends up at rest. Okay, so here the total change in kinetic energy is zero. Therefore, the net work done on the object is zero. So the question is, how is that possible? We know that there is an external force acting on this object and it raises the object by height equal to h. Okay, so let's look at the free body diagram here. So let's look at the free body diagram, and if here is the object of mass m, then the external force acts upwards in order to raise the object, and it counteracts the force of gravity, that is the weight, which is acting downwards. Now Fext, the external force, equals the weight of the object. Okay. Therefore, if you take away mg from the external force, so the net force acting upwards is Fext minus mg is indeed zero. So what happens here is that the work done is the net force times displacement integrated, okay, from an initial position A to a final position B. Now in this particular case, if F net is 0, work done is going to be 0 for sure. So that's the interesting part. Okay, so people would probably ask, if there is no real external total force on the object, how is the object even moving, right? So the object is permitted to move, okay, by Newton's first law. it is not permitted to accelerate, it is permitted to move. An object that's in motion can continue doing so, but an object at rest can continue being at rest as long as it's not acted upon by an external force. Right? So, so in principle, one could take this object and give it a slight nudge, and this object will travel very, very slowly upwards. Right? Uh, So in that particular case, the initial kinetic energy here at point A would be equal to the kinetic energy at point B, and then the difference would be zero. Okay? So the net force here acting on the object is Fext, is the external force, minus mg, and that is zero. Okay. So the next question to ask is, if the network indeed is zero, then how does the object or the body accumulate potential energy equal to mgh? Right? Clearly, its internal energy has been raised, okay, in going from point A to point B. So, in order to better understand that, we will need to define our system as being the earth here. This is the earth, okay, or the ground, and the body itself, right? So the earth and the ground as being the body. I've just drawn a really big box to make it easier to understand. So what is happening here is that the external force that acts on this object, okay, acts on this system rather, raises the object by height equal to h. Okay? It changes the internal configuration of the system. So clearly what we are doing is that we are applying an external force, okay, on this system in such a way that this particular body is raised by a height h. Okay, so in such a case, the work done by the external force is Fext times h. Okay, and Fext being equal to mg, okay, and times h, okay, will result in the change in the potential energy of the body. Okay. So it is useful to understand, how to define a system, okay, in order to obtain the work done by an external force, and how that results in changing the body's potential energy. Right? It is also necessary to better understand how the work done on an object results in the change in its kinetic energy. Okay, so this is a very important principle to consider, and one should be very careful in defining the forces and determining the work done in order to determine whether there is any change in the potential energy of the system or kinetic energy of the system, and so on and so forth. Okay. I hope this helps us to get a better appreciation, okay, of the work energy relationship.